okay, this is amazing stuff. How does someone, an individual person,
Mm.
is there stuff that we can take away here? Are there
Yeah.
like truths that, you know, maybe as part of our day-to-day lives that we can sort of integrate
Yeah.
ideas like from this, or is there anything from your own life, perhaps
Yeah. Yeah.
examples of things that this has illuminated for yourself?
Yeah. Well, let's put it this way. I mean, I don't know if anything from this paper will revolutionize the day to day like mundane life, but a lot of people, but I'll let's try to pull in that direction. A lot of people think about evolution, and one of the things that always bugs them, and especially a lot of engineers too, is this standard story of well, we make random changes and then we pick the good ones, right? I don't know about you, but when I first learned about this, I had been building electronics and things like that as a kid for some years, and then I learned this theory, and it sounded laughable. It sounded like you're telling me that I'm going to make random changes in this thing. I huff and puff for many hours, and then the person who made these transistors and everything else will put in even more work than that. Like we're all busting our butts on this stuff, and you're going to make random changes, and you think eventually things will get better. Like that's if you've ever built anything or written code, that sounds crazy. And then okay, so you learn some things about modularity and evolvability and some things that, but a lot of people are still left with this idea that okay, in theory it might work, but we kind of know that genetic algorithms, they did great for a while, but they sort of peter out. There's some there's kind of limitations to what they can do, and in particular, but part of what makes it a little challenging is what Andreas Wagner, which I think his work is amazing and important. What he calls the problem of the arrival of the fittest, which is that if the best solution is hiding somewhere in your population, I suppose I'll give it to you that eventually we'll sort of find it and let it expand. But who guaranteed it was there in the first place? How do you know that the right solution is ever going to be there, depending on what your problem space is? So anyway, so a lot of people are still left with this, this dissatisfaction about how do we know that there's been enough time for this kind of process to give us the amazing things we see in the biological world? And I'm not talking about that. I mean, so there are some people that will never buy the story because they are fundamentally like committed to another kind of story. I'm not talking about them. I'm talking about
Sure.
people with a scientific kind of worldview that want to understand in a naturalistic way what's going on. But the standard story doesn't seem like it's the whole story, right? And there's a lot of very smart people who are sort of thinking along those lines. So what I would point out, my kind of contribution to that is this: part of what makes that process so magical is not just the process itself. It's the fact that you're working on a material that's smart. You're working with an agential material. That's part of where the power comes from. If the whole thing seems tough to you, add to your sort of mental picture the fact that it's not really searching the incredibly difficult and large space of all the possible things that could happen. What it's searching is the space of behavior shaping signals by which cells tell other cells what to do. And that's a much easier space to search, right? If you're dealing with, if you run that rat circus, you could try to come up with a kind of an optogenetic strategy to control every neuron to get the rats to sort of do whatever they're going to do. That's really hard. We'll be here till the sun burns out before we get all the, before we can
Right.
micromanage it. But you don't have to do that because you can train the rats. And that's a much easier. I mean, it's still a bit of search because you still have to figure out, well, what's the reward, what's the punishment, what are they capable of? Do they do place conditioning? Do they do associative learning? Like what do they? So there's still some searching involved, but it's a much easier problem than going bottom up. And so this is what I want people to take away from this: is that part of what makes evolution so magical is that it's working with an agential material that has tons of competencies. Evolution is playing with hardware that is so far in capability, and I don't mean the fact that it goes down to the nano level, and I don't mean that it's in fact, it's way noisier and more brittle and whatever than all the things we try to build. Despite all that, it is so much more powerful than anything we've ever made, because it is not a single specific thing. It's a learning machine, so to speak.
Yeah.
And
Right.
that gives evolution, that puts evolution on
Mm.
steroids. That's what I think is a huge motivating factor. And I think until we understand that, we are not going to have, I mean, that's to me, that's, if I can dare to say this, the thing that I think is missing from the standard evolutionary synthesis is this: it's the appreciation of the intelligence of the substrate. It treats the standard story, treats the substrate as a bunch of dumb Lego blocks, and everything changes when the material has agendas. Everything changes, and evolution changes massively. So I don't know if that counts as everyday life for people. I suppose some people think about that stuff every day. So
No, no, it's good. I find it useful because it's a frame, it's a perspective on how you look at the problem. I mean, this is something we talked about in round two. I think like polycomputing and
yeah,
the role of the observer. The same thing can be computed, but depending on how you look at it, you actually are extracting that different value, different utility from the same exact thing. So yeah, no, that's wonderful. And actually, I think this will just looking at the time a little bit here. I do want to cover a little bit about the biology, Buddhism, and AI paper. I think it was care as a driver of, I forget the exact, yeah, care as a driver of intelligence, which you worked on with a few collaborators, Dr. Witkowski, Salmanova, and Dwayne. And this, I think, actually, yeah, kind of does bleed into this fairly well, because in the Agential Materials paper, you mentioned the idea of like beginner mind. And you have a quote from Suzuki about in the beginner's mind, there's many possibilities, in the expert's mind, there are few. So you kind of want to have a frame of like always being, having a frame of always being a beginner and being like open and curious to things all the time is a lot better than, this is straw manning it, but it's a lot better than being an expert and being like, I know everything. I've mastered. There's nothing else left to go, right? There's always potential for more learning and more mastery. So for the biology, Buddhism, and AI paper, would you mind providing us again, just a brief overview of the overall paper, and also how you got interested in this topic to begin with, and how you got into this group of folks who are studying this?
yeah. Well, how I got interested in it, I've been interested in these kinds of things for a really long time, both from the perspective of kind of Eastern thought about the philosophy of mind and things like that, and more broadly questions of concern and compassion and things like that. How we met up. To tell you the truth, I don't remember who reached out first. It might have been Thomas Doctor that emailed me. I mean, Olaf and I have known each other. He's a great contributor to the artificial life community, and so I've known
Mm,
him and his work for a long time. Bill and Eliza and Thomas I met afterwards. Yeah, I don't recall who made the first, but anyway, we've been talking about this stuff and thinking about it for a long time. And there's actually a second paper that it either just
oh,
got accepted or we just returned it. I don't remember exactly where it is, but there's a second paper following up on all of this stuff. You can find the reprint, the preprint
yeah.
is on my website. But this idea of specifically this idea of care and what do agents care about, and it for me it has lots of important implications, because I try to understand collective intelligences, and so if you're going to have a collective intelligence, what is it going to care about?
Mm,
We don't have a good science of that. And
right.
then there's the notion of embedding care in artifacts that we make. So robotics, AIs, what are they going to care about? It's a funny kind of a funny story when my youngest was I want to say he was 3 or 4, and he said, we used to build stuff together all the time, and we did all kinds of engineering things, and one day he said to me, let's make a cat. And I said, well, like a robotic, you want to make a robotic cat. And I said, well, let's make a list of what are the design specs here, like what does this thing need to do? And he says, well, it needs to move around. Yeah, maybe like that may be doable. And it needs to, make meowing noises. I'm like, yeah, that's pretty much doable. And it needs to,
Sure.
there was something else that it needed to do. And I said, yeah, probably we could do that. And then he says, and it needs to care. And I said, you
Mm.
mean, what do you mean? You mean it needs to like walk over to you and let you pet it? He goes, no, not act as if it cared. I want it to actually care. And I was like, all right, well, that's it. You've just broke the whole project because we don't have a clue as to how that is going to happen. And that is, that figuring out how that uh ties into the whole the cognitive light cone story that I've been telling, and the kind of the spectrum of persuadability. It's like intelligence is one thing, problem solving is one thing, but where does the care come from, right? And what do we mean by that? And a lot of people say things like, I care about stuff. That's just a machine. Well, they're usually pointing at some AI thing or some, robot or something. And they say, well, that's just the machine.
Yeah.
Machines can't care. And like, well, you used to be a single cell. And paramecia, do paramecia care? Because now you got a problem. If you say that the paramecia care, then, well, guess what's inside a paramecia? A bunch of molecular cogs and wheels. So it's you gotta so maybe machines and certainly molecular biologists see single cells as a kind of machine, and that analogy has done pretty well for us. On the other hand, if you say no, the paramecium doesn't care, it's just a bunch of chemical reactions. I mean, we can sort of see what's going on in there. It's a bunch of chemistry that doesn't care. I care. Like, well, you used to be a single cell. So why don't you tell me where when the care got beamed in, like what stage of embryogenesis
Right.
does the care get
Right.
beamed down, right? That's a problem too. So
Mm.
so you got this real issue with people who think in binary categories. They get trapped in this pseudo problem that's I think unsolvable.
Yeah.
So anyway, so we were really interested, and then of course from their perspective, they're interested in the questions of, there's a Buddhist story about care and compassion and those kinds of things. And so I was interested to see how compatible those things are. Can we use some tools from that thought? I mean, there's a whole other thing, which is this notion of the impermanence of the self. And it
Mm.
goes, I mean, there are obviously all different kinds of opinions on this, all the way from there is no such thing, it's a total illusion, right? That's one set of views. And then on the other is the kind of like the sort of the man on the street version, which is well, I've got this permanent self, and it's this like thing, and then it's, it exists. And then what I'm interested in is kind of the space in between, which I think is more accurate. So, and by the way, I'm no Buddhist scholar. I don't pretend to like know who thinks what in that area. I'm just I'm trying to keep up with Thomas and Elizabeth and so on. But there's an intermediate version, which is that it's not that you don't exist. You do, in the same sense as everything else exists, which is as a useful metaphor. And in fact, you are the most useful metaphor for all of all, because you might somehow do away with metaphors of talking about I don't know what social structures are, what grocery stores are. Maybe you don't. Maybe you now see like Eddington said that a table is mostly empty space, and so maybe you've internalized physics enough to know that even the table isn't the great metaphor, that it's
Mm.
mostly fields and whatnot. Like all of that is fine, but there is this metaphor of a of a self that can do things, because it's on you to do stuff or not do it. You have to make those decisions. That's a pretty useful metaphor. So I don't think it's not real. I think it is real in the same sense that everything else is real, which is a useful construction. Also, I think what's useful about it is that it is continuously self-constructed. And here's what I mean by that. At any given moment, so right now, you don't really have access to your past. The only thing you have access to are the engrams left in your brain and body by your past experiences. That's all you have access to. And from that, you reconstruct a story of your past. So including, the school you went to and various other things. You're building that right now at every moment. It's a little bit like, anterior grade amnesia patients who can't form new memories. And so they use these scratch pads, at least some of them, where you write down, the first thing you write down is that I have anterior grade amnesia, and then some stuff that happened. And then at the end that says, oh, and don't forget, write this note again tomorrow. And right. And that's your, like most of us have the same thing. It's just internalized, but now they are using this stigmergically, this outside tool, because there's some problem.